Hi, my name is Tibor Kolena, and I would like to give you some information about the local on-load isolator switches. So in this short video, I would like to talk about what is a local isolator switch, what are the differences between the traditional switches, on-off switches, and between an isolator switch, what are the requirements, and when especially you are going onto the field, what points you need to take care about and what you are looking after. So first, what is a local isolator switch? As the name indicates, it's an isolating device used for isolating the electrical energy typically from a motor. Provides a convenient and safe isolation point when we are doing some maintenance or some measuring activities or any other cases when we need to get in touch with the equipment on the field. Now we will show you a single line diagram, a basic single line diagram, where we can put in context how it's connected to an electrical system. On the picture, you can see a typical arrangement from a one-directional motor. The motor indicated on this single line diagram with an M in a circle on the left bottom side of the picture. On the left upper part, you see the L1, L2, L3. These are the three phases, and you can imagine it's installed in an electrical room and supplied to a motor control center called MCC. On the left side, we can see the main circuit, where we have installed few main components like switches, protection devices, and contactors. And when we are going down on the left side, we see the motor, and just at front of the motor, we are installing the local on-load isolator switch. You can see it's marked with a dashed line around local on-load isolator. And here we also have some control devices like local push buttons for start and stop. On the right side of this picture, we can see the control circuit. Now we know how it's installed in the network. Let's see what are the major differences between the local isolator switch and between the traditional on-off switches. First of all, and the most important thing, the isolation switch is isolating the equipment and used for this purpose mainly, not for normal operational use. The on-off switches for normal operation use, and this is for daily operation. The local isolator switch, by the relevant national codes and standard, ISC and US standard, certified to be able to use as isolating device. The on-off switches are not necessarily rated and certified as isolator switches. The isolators are always installed in the main circuit, never in the control circuit. The on-off switches could be also in the control or in the main circuit installed, depends on the application. Also, it's very important to mention on the local isolator, you should have physical blocking capability, which means in off position, you should be able to place your padlock, your personal padlock, or depends on the local practice, the equipment padlock. Compared to the on-off switches, if you're just thinking on the typical light switches, you will not have this feature installed. If you are going to the field, what you want to see and what you are looking after. On the picture, you can see a typical local isolator switch in an enclosure. And the cable connection can be from the bottom or from the top, depends on the arrangement. Least two cable glands you need to find on a local isolator switch. These are connected to the main circuit, the incomer and the outgoing. And the third cable could be connected for the control circuit for additional functions like local start and local stop functionalities. The handle of the local isolator switch should be accessible without opening the electrical enclosure. You should be able to identify the direct cable connection from the local isolator switch to the motor or to other electrical equipment it's designated for. The isolator switch should be visible from the equipment itself, so when you are starting to perform any activities on the device, electrical device, for instance on a motor, you should be able to see the position of the isolator switch and to make sure finally it's logged in off position. The unique identification with the hack code, permanent labeling should be installed on the isolator switch, which should be matching together with the motor or electrical equipment which intended to isolate. Also, there are some common sense condition evaluations as well. For instance, if you see any damage or loose cable connected to the isolator switch, or the switch itself is broken, or the electrical panel, electrical enclosure is damaged or open, do not accept this isolator device as a safe isolator device. Please ask the local electrician and report the findings. So let's summarize what I was talking about concerning the local isolator switches just in the last few minutes. These are devices providing electrical energy isolations in the electrical energy network. They are certified to do so by the relevant IEC or UL standards. It's not for operational use, it's just for the isolation, for the safe isolation and convenient isolation of the equipment. It's always installed in the main circuit and used up to 1000 volt, which means on the low voltage systems. Always you need to find the hack code for identification labeled on the equipment permanently, and you need to be able to read it, and you need to find the hack code on the isolated equipment itself. You need to be able to place your padlock in an off position. If you have any doubt concerning the isolation point or the condition of the isolator, please ask the local electrician for further support. And do not forget to isolate all the other energy sources defined by the Fatality Prevention Element 2. If you need further information, more technical details on this subject, please feel free to contact me or with my colleagues. And please visit the Global Electrical Automation and Instrumentation portal, and the link you will find below in the subscription of this video. Thank you for your attention.